Good morning, everyone. My topic for this morning is all about green walls. So, before we start, I would like to discuss to you the flow of my presentation. First, we have the introduction defining what are green walls. Second, we have history of green walls where it all started and developed. Third, we have the classification of green walls discussing the types of green walls. This topic defines different systems according to their characteristics. Fourth, we have the irrigation technology in interior living walls. Fifth, we have the main factors we have to consider in building green walls, such as its irrigation system, the cost, maintenance, and etc. Sixth, we have the benefits of green walls, of how it affects and contribute to our environment. And lastly, we have the conclusion. Now we will be heading to the first part of our discussion. So what are green walls? According to Stafford University Green Wall Center, vegetation growing on or against a vertical surface. To make it more understandable, green walls are vertical structures that have different types of plants or other greenery attached to them. The greenery is often planted in a growth medium such as soil, stone, or water. So, as we all know, green walls have become a rising new trend of built environments in recent years. Incorporating living nature into urban environments not only looks that are much more inviting but also has several other benefits and purposes. But before this, we should also know where it all started. So as you can see, this is all familiar to you guys. This is the Hanging Gardens of Babylon. They were famous because of the remarkable feature of engineering with an ascending series of tiered gardens containing a wide variety of trees, shrubs, and vines resembling a large green mountain constructed of mud bricks. So green wall is the common term to refer to all forms of vegetated wall surfaces. As you can see in the picture, they used traditional green wall methods. So they are historically known since the Hanging Gardens of Babylon and the Roman and Greek empires. Now we move on to the important developments that green walls have progressed throughout the years. In 1920, the British and North American Garden City movement promote the integration of house and garden. In 1988, introduction of stainless steel cable system for green facade. In 1990s, introduction of cable and wire rope net systems. In 1993, the first major application of a trellis system in California. In 1994, we have the indoor living wall with biofiltration system, and it was installed in Canada. In 2002, the MFO Park opened in Switzerland. The project featured over 1,300 high park climbing plants. In 2005, the Japanese government sponsored a massive green wall in Expo comprised of 30 different modular green wall systems available in Japan. And lastly, in 2007, Seattle implements the Green Factor, which includes green wall. So what is the Green Factor movement? So it was implemented by the government in Seattle that this type of rule is a score-based code required that increases the amount and improves the quality of landscaping in a new development. So landscaping plays an important role in how new development looks and functions. So they considered as well-designed landscaping as first, it improves the look and feel of a neighborhood. Second, it reduces storm water runoff. Third, we have cool cities during heat waves. Fourth, providing habitat for birds and beneficial insects. And lastly, for them, it decreases crime. Now let us move on to the classification of green walls. So considering the recent developments in green wall technology, it is important to identify and classify all existing green wall systems according to their construction techniques and main characteristics. So green wall can be subdivided into two main systems. We have the green facades and living walls. Under green facade, we have the direct and indirect. And one example of direct is traditional green facades. And on indirect, we have two, which is cable or wire rope net system and modular trellis panel system. So for the other system, living walls are a quite recent area of innovation in the field of wall cladding. It can be classified as continuous. We have continuous and modular. Under continuous, we have an example of lightweight screens, and in modular, we have foam substrate, planter box, and felt layer. So these three types are a growth medium for living walls. So now let us discuss first the first system, which are the green facade. So what are green facade? Green facades are based on the application of climbing or hanging plants along the wall. Plants can grow upward the vertical surface like traditional examples, or grow downward the vertical surface in case they are hanged at a certain height. Green facades are light to install and generally aimed at supporting the natural development of plants, mainly climbing plants that can have evergreen foliage or deciduous and reach until 25 meters of height, taking, however, for some years for the full coverage of the wall. So as you can see, green facade is more on the traditional side. They let the plants grow and stick to their walls. So that's why one of the example is the traditional green facade. So now we'll be discussing the two types of green facade. We have the direct and indirect. So direct has an example of traditional green facade as discussed earlier. So what is traditional green facades? So traditional green facades are considered a direct greening system consisting of using self-clinging climbers rooted directly on the ground. So we have an example here, direct green facade. It is a private house in Goliga, Portugal. Now let us move on to the another type of green facade, which is the indirect. We have the cable or wire rope net system, the continuous one. So cable or wire rope net system, it applies high tensile cables to accommodate numerous pattern and sizes. So this is the picture as you can see. Next, we have the modular trellis panel system. So this is a lightweight three-dimensional panel made from a galvanized, as shown in the picture, and welded steel wire. Okay, so now we move on to the another type of green wall system, which is the living wall. So what are living walls? So living walls are usually attached to an existing structural wall. One of the aspects of these walls versus others is the variety of plants that can be utilized in their construction. Unlike some of the previous system that was discussed earlier, you do not need to use a plant that can climb its way across a grid and can instead use a wide variety of plants for aesthetic purposes. So as you can see, the previous type, which is the green facades, we are much more limited. We use plants that can grow up high, while in the living walls, we can use different types, a different variety of plants. So we move on to the classification of living walls. We have continuous and modular. So continuous living wall system are based on the application of lightweight and permeable screens in which plants are inserted individually. So one example of it is lightweight screens. So as you can see, this building is one example of continuous living system of Caxa Forum in Madrid, June 2013. So they used lightweight screens. Next, we have the modular. So modular living wall systems are elements with a specific dimension, which include a growing media where plants can grow. So each element is supported by a complementary structure or fixed directly on the vertical surface. So we have a growing medium. We have three examples, right? We have foam substrate like this, a planter box, and lastly, we have felt layers like this. For us to understand and identify more the classifications of green wall, there are some diagrams that I will show to you so we can differentiate green facades from living walls. So as discussed earlier, Green facades are based on the use of climbers attach themselves directly to the building surface, as in traditional architecture like this. So this is an example of direct green facade. So a diagram is shown so that you'll be more, you can picture it. Next, we have the indirect green facade. And lastly, green facade can also be indirect green facade but with a planter box. Now we move on to the living walls. So it is predominantly seen as exterior and interior application. So it is for both. So as discussed earlier, living walls can be classified based on their application method. First, we have the continuous living wall system. It does not require a substrate of soil, but plants grow in lightweight, as given example earlier, the lightweight screens. On the other hand, the modular living wall are characterized by pre-vegetated panels with specific supporting elements such as planter boxes, felt layers, and foam substrate in which plants can grow. So now that we are more familiar with the classification of green walls, it is also necessary to introduce one of the general function elements of green walls, which is irrigation. So what is irrigation? So irrigation is the process of applying water to the crops artificially to fulfill their water requirements. Nutrients may also be provided to the crops through irrigation. So we all know that plants need water to survive, right? Without it, your green wall would quickly become a brown one. That is why behind the captivating facade of plants that you can see, you will find an irrigation system working hard to keep your living wall hydrated and healthy. So many different green wall technology exist and new ones are being developed every year. So first, we're going to talk about the hydroponic irrigation system. So it is the process of growing plants in sand, gravel, or liquid with added nutrients but without soil. So, so in this type of irrigation system, we have three types of hydroponic irrigation system. First, we have the hydroponic systems in liquid medium. So these systems have not substrates for crop development, which is produced directly on the water-bearing system by various plants such as, first we have the floating shelves. So for the floating shelves as shown in the picture, in deep flow hydroponics, well-rooted plants are placed in a net pot on a floating plate in the liquid reservoir like a raft. To stabilize the plant, the net pot may be filled with substrates such as clay balls. The roots are hanging directly in the nutrient solution, which is very well oxygenated. So this is done by the means of air pump, as you can see. So under hydroponic systems, we have another system for water depth, NFT. So for NFT or nutrient film technique systems, it is characterized by a permanent flow of nutrients in a thin film around the roots. A pump transports the nutrient solution on an inclined plane, as shown in the picture, such as tube on which the plant roots lie. So they are continuously watered and supplied with nutrients. So the contents flow prevents nutrient accumulation. Lastly, we have the deep flow hydroponics. So lastly, for the deep flow technique, it is actually a variant of NFT technique. The deep flow technique makes this type of hydroponic system safer as the roots are still supplied in the event of a pump failure. However, the method is not applied very often since especially in no longer or larger systems, the supply of oxygen to the plants varies, resulting in an uneven plant growth. So they usually use this type of two system, the floating system and the system for water depth, or as we call NFT. So another hydroponic irrigation system that we have is the hydroponic substrate system. So in these systems, In these systems, we grow using inert substrates irrigated by drip irrigation, which is the most used type of hydroponic substrate system and can be classified as recirculating or not and non-recirculating sub-irrigation or exudation. The most common substrates are expanded by clay balls, perlite, or coconut fiber. So the substrate or growing medium serves to keep the plant in place as well as provided an environment the root system can function in. The crops may bench or grooves, grow up in a bag, growing in individual containers or channels, and lastly, growing in a surface or sanded. Here we have an example of non-recirculating system under drip irrigation. The plants are always supplied with fresh and equal adjusted nutrient solution. Nothing is circulated so that we can avoid the spread of pathogens. However, this process consumes much more water and nutrients get lost because it is not being recirculated. So we have to change water from time to time. Another example is we have the recirculating system, which the nutrient solution is collected and returned to the plants via a pump. By this, resource consumption is much lower. The sprinkling frequency is adapted to the needs of the plants and controlled by a timer. Excuse me. So lastly, we have the aeroponic systems. So aeroponic systems, in an aeroponic farming system, the roots of cuttings or plants do not hang in a liquid but in a mist of a nutrient solution. The plants are hung with net pots in a chamber where the roots are sprayed or misted through water nozzles with nutrient solution. So as you can see from the diagram. So lastly, here we have a hydroponic wall diagram for you to imagine what it's like in a living wall with your preferred type of hydroponic irrigation system. So another irrigation system for living wall is lastly we have the aquaponic irrigation system. So aquaponic is an interlinked bioculture system. It consists an element of aquaculture, which means production of aquatic species or fishes, plus the hydroponics, which also means production of plants without soil medium. Combining them together, we have aquaponics, the production of both aquatic species and plants without using soil medium. So how does aquaponic work? Here is a diagram that I will show you for us to understand more. So the first step is we have a rearing tank for fish. It can be tilapia, catfish, or etc. In this step, fish are fed fish meals and produces ammonia-rich waste. The second step, as you can see here, we have the plumbing connecting rearing tank to a settling tank. Third, we have here is the settling tank for solid collection and biofiltration. The ammonia breaks in this process, turning nitrites to nitrates, and plants take the covered nitrate to nutrients. For the fourth step, we have the plumbing connecting to settling or biofiltration tank to deep water culture beds. For the fifth step, we have the deep water culture beds for hydroponic gardening. Here we have the plants remove nitrates and nitrites for the system. Sixth, we have the plumbing connecting to DWC sump tank. The final step, we're in the sump tank with pump pushes water back to rearing tanks, meaning clean water is pumped back to rearing tank. To give you an overview, here is another diagram of aquaponic irrigation for living wall system. So now we will move on to the major factors we have to consider in building a green wall. So first, we have the elements of living walls. The elements of living wall, we should be aware of what plants we should use in building a living wall. So here are some plants for us to be more familiarized what to put. We have the indoor green walls for shaded areas. So these are the examples. And for outdoor or exterior green walls, we have these plants. Second, the maintenance of having a green wall. Since plants are involved, we must keep in mind that different plant has different irrigation and nutrient requirements. Also, in green facades under indirect irrigation, cable and wire rope system require periodic checking to ensure that the elements are properly in place as the plants mature. And as for living walls, it requires regular irrigation, and degree of maintenance required will depend on the type of living wall system and the vegetation used. Third, for the green facade, it is important that the attachment to building envelope are right, calculation of structural loads, um, plant selections, plant maintenance, registered manufacturers, and trained installers. Fourth, the factors affecting living walls. We have the irrigation, plant selection again, consideration of the microclimates and the growing mediums that are used to support the plants. And lastly, we have the cost. We all know that it is quite expensive to build green walls, especially with living wall systems. Another thing that we have to take into consideration is the project size, design team costs, system type, support structure requirements, building location, complexity of design, and the use of standard for or custom components. For the benefits of green walls, we will be discussing first the public benefits. First, we have the aesthetic improvements wherein green walls can reclaim disregarded space by providing aesthetic stimulation where it would not otherwise be found. They can also serve to create privacy and sense of enclosure while limiting the negative physical effects associated with property demarcation. Second, it benefits us to reduce of the urban heat island effect. The reintroduction of vegetation into urban environments promotes the occurrence of natural cooling process such as photosynthesis and evapotranspiration. Third, improved exterior air quality. Green walls mitigate air pollution levels by lowering extreme summer temperatures through photosynthesis, trapping particulate matter, and capturing gases. Lastly, we have local job creation. Green walls draw upon several disciplines for their design, installation, and maintenance, such as landscape architects, irrigation consultants, and many more. So the demand for local supply of plant materials, blended growing media, greenhouse production, and fabrication of structural frames creates further business activity. Now we move on to private benefits. First, we have the improved energy efficient wherein green walls can reduce the temperature fluctuations at the wall surface from a range of 10 to 60 degrees to one of 5 to 30 degrees Celsius, in turn limiting the movement of heat between building walls. Next, we have the building structure protection. So, as you can see, temperature fluctuations over a building's lifetime can be damaging to organic construction materials in building facades. So, green walls provide an additional layer of exterior insulation and thereby limit thermal fluctuations. Third, we have it benefits us also by improving indoor air quality. So air that has been circulated throughout a building with a strategically placed green wall, such as near an air intake valve, will be cleaner than that on an uncovered building. The presence of vegetation indoors will have the same effect. Fourth, we have the noise reduction. The vegetated surface provided by strategic urban greenery such as green walls and roofs will block high-frequency sounds. Lastly, we have the marketing potential. Green buildings, products, and services now possess a competitive edge in the marketplace. Green walls are an easily identifiable symbol of the green building movement since they are visible and directly impact the amount of green space in urban centers. Next, we have the design specific benefits. First, we have the increase in biodiversity. Green walls can help mitigate loss of biodiversity due to the effects of urbanization, help sustain a variety of plants, pollinators, and invertebrates, and provide habitat and nesting places for, for various bird species. So another, we have improved health and well-being. Buildings that feature and promote access to vegetation have been documented as having a greater positive human health impact than those without. Third, we have the urban agriculture. Green walls offer the opportunity for urban agriculture such as vertical gardens of small fruits, vegetables, and herbs. Fourth, we have the on-site wastewater treatment. So several water recycling systems can be applied to green walls. These systems pump gray water through a green wall, which then passes through filters, gravel, and marine plants. So treated water is sent to a gray water holding tank for household or irrigation use or released into the public water treatment. So some of these systems also collect storm water which is filtered for household and used for irrigation purposes for us to save more. Now, for the last part of our discussion, we have these conclusions. We know that the analysis of the most relevant system in the field of green wall system demonstrate that there is a significant evolution in this field. So as you can see now that green walls are evolving, there are new technologies coming in. We can see potential that green walls can help our community by those benefits that I have mentioned earlier. Next, we have the main factors concerns are to find new strategies for a better performance and durability through the integration of water retention materials, drainage means, and simpler assembly and maintenance processes. Third, we have the system's adaptability is still a field of development. New solution must focus not only on the application in new buildings, but also in the rehabilitation of existing buildings, introducing greening in historical areas. And lastly, considering the analysis of different types of green wall systems, it can be understood that innovation is mostly centered in the improvement of their design to achieve a better performance during the installation, usage, or maintenance process. So that's it for this topic, guys. Thank you so much. So I hope you learned something today. Thank you.